So my name is Joris van den Bossche. I'm from Belgium, but currently working at the Paris-Saclay Center for Data Science at INRIA here in Paris. And I'm a Pandas core developer. And I'm in this talk want to give you a little bit an idea of what is at the moment going on in the Pandas library. I assume that most of you are already familiar with Pandas, and otherwise you already got a nice introduction to one of the features of Pandas, so I'm going to skip this slide. But basically, Pandas is really targeted at the tabular structured data. If you have heterogeneous data, then you have a set of powerful tools to work with them. So what is going on in Pandas? We had recently, a month ago, the 0.20 release, and I'm going to highlight a few of the new features, changes that were included in this release. Of course, there was a lot more that I'm not going to talk about, so you can always look at the full release notes to see all the details. But I'm going to highlight a few of them. One thing you might find useful, you could already display data frames, for example, in a notebook. The HTML display, you could already make some conditional formatting, for example, highlighting missing values or highlighting the maximum, or have a background based on the value in the cell. So that was already possible in the notebook with HTML display. But now we also have experimental support to export formatted data frames to Excel, thanks to contribution of Joel Notham. So using the .style attribute, you can now export to Excel with some formatting. So if you need to do that, that can be useful. Another display-related change is in the last release is related to the JSON table schema. So it's a way to specify the schema of your data, so which fields you have, which columns you have, which attributes you have, using JSON. And Pandas added added an export function to this specification, and then this allows tools like the Jupyter Notebook or related tools like Interact or Jupyter Lab to build better, more interactive displays of your data frame in the notebook. This is not enabled by default. You have to set a setting to true, but then you can get a better display. At the moment, it's still rather basic in the tools, but in principle, you could have, for example, sorting on a certain column that could be built in just in the display. So if you are interested to improve and improve those display, there are a few links to the package that provides this for Jupyter and for Interact. Another new method is the aggregation method. You probably, if you know groupby, you might be familiar with the groupby.aggregate method, so which lets you apply a set of different aggregation functions at once. So now we also added this to a data frame to make it more consistent. The methods you can use on a groupby object or a resample object, rolling object, as on a data frame. So for example, if you have this small data frame and you want to calculate the minimum of each column, but also the mean of each column and the maximum, and to combine in one table, you can now do this in one step using this aggregate method. A new index type that was added was already mentioned by Alexander, but I'm shortly going to explain it. Let's see oops, sorry. So what is an interval index? If you're not familiar with interval trees or interval, the kind of data structure, so you can think about samples or data where you have start and stop values. For example, you can have a data frame where you have a column with a start date and an end date, or with a start location and end location, so, or any other physical measure with a start and an end. So you can put this in 2 columns, but by the introduction of the interval object, you can put it in a specific object for that, and you can put it in the index, and that enables some to more easily work with such kind of start and stop ranges. For example, from Wikipedia, so it allows you to efficiently find all intervals that overlaps with any given interval. So you can very easily, if you have a lot of such intervals which might be overlapping, just to find all your rows where a certain point is included in. So, small example how you can create it. So I made a small index with the intervals from 0 to 10, from 1 to 5, and from 2 to 3. So partly overlapping intervals. And then you can efficiently index those ones. So for example, I want to get all elements of my series where 1.5 is included in the interval. Of course, this is a very dummy example, but it can, for example, be used if you use the pd.cut function which bins your data. You will get some kind of those data type. But also, if you have gridded data or sequences in genomics, typically use such interval objects. So this is an experimental new feature. So if you have data that could be used in such type of objects, very welcome to try it out and give feedback on the usage. There were a few enhancements or new features. We also had a bunch of deprecations. So also Alexander already mentioned the panel was deprecated. So panel was a 3D object to work with, but the problem with the panel that it's actually there are no core developers who are actively developing it. So it got not as much attention as the 1D series 2D data frame. So we decided to limit the scope of Pandas to just tabular data up to 2D, and therefore to deprecate the panel object. You have some alternatives. For example, if you still work with data frames using multi-indexes, you have some way to introduce multidimensionality in your data. But you also have the very nice X-array library, which combines the general ND-dimensional arrays of NumPy with the labeling, the indexing of Pandas. Another method that we deprecated, which probably will impact more users, is the IX indexer method. I'm very happy that Alexander didn't mention it, which is very good, because in principle you don't need it. There are a few use cases where it's nice to use, but from most of the use cases you have better methods. So for example, just to illustrate why we deprecated this one, a small example. So I made 2 series, S1, S2, with the same values but a different index type. So the first one has some integer index values, the other one has string index values. So the big question, and it's what makes indexing in Pandas powerful but also very complex at the same time, is that you can do both positional indexing. I want the first row, the second row, or you can do label-based indexing. I want a row with the label 0, or I want a row with the label B, for example. So the question, if you do a certain indexing operation nowadays, which one of the 2 will it be? And well, that's with the IX method a bit the problem, is that it's not clear which one of the 2 it will be, or at least there can be some confusion. Because you will see, in this case, it does something different based on the type of the index you have. In the first case, it's label-based. You get from 1 up to 3, including 3. But in the second case, it's actually just positional. So it falls back to positional because you don't have an integer index. So, and that makes it a bit confusing. You can't directly see if you use IX, which one of the two will it be, while you can just use iloc if you want to do positional, or loc if you want to do label-based. So, and that's the reason that we deprecated the IX methods. So, in the last release, there are quite some deprecations. We also did some, try to clarify some of what is public API, what not, which might give some breakages if you use the very, some methods deep inside the package which were not supposed to be public. If you build libraries or tools based on Pandas, best to check out this link where there is a bit summary of what is now regarded as public, what is not regarded as public. We also try to remove some of the inconsistencies, and this effort is to go to Pandas 1.0. I didn't put the date here. We hope that it's somewhere this year, but as always, certainly with open source, it can certainly be a bit later as well. And also, so it's still an ongoing effort. There's still some things that we like to clean up before putting the 1.0 name on it. At the same time, there is also, Pandas has grown quite into a very complex beast. Certainly the internals of Pandas, there are also quite some known limitations. I will come to them later. So targeting a Pandas 1.0 is certainly not an endpoint, but it's more to say, okay, this is the current status of Pandas, so we can now work towards a Pandas 2.0 with some major enhancements that try to overcome some of those known limitations. Before I go to what would be, or what are the ideas about Pandas 2.0, a very brief side step to some of the broader data frame ecosystem. One of the projects that recently have emerged is the Apache Arrow project, which works on in-memory columnar analytics and tries to build build with a lot of different communities, also with Python community, but also with many other communities that work with data frames, and try to set better interoperability between all those projects by having a common memory layout, specified memory layout, and tools to work with that. Why am I mentioning this? Because it's first a very important evolution in the data frame analytics sphere, but also because Wes McKinney, the original creator of Pandas, is heavily involved in this, and the future of Pandas, what we say like Pandas 2.0 will be heavily inspired on those efforts. Very short, a practical example that is related to this is the Parquet format, which is an efficient columnar storage format. Is used a lot in Hadoop ecosystem, things like that, which will now have due to the Arrow project have bindings for Python, and for now you can still use the PyArrow or FastParquet libraries, but in the future there is a PR for that. We might also have just a read Parquet and toParquet methods in Pandas, using those PyArrow or FastParquet libraries. So Pandas 2.0, we don't even yet have a Pandas 1.0. We're still thinking about it. As I said, it's quite complex code base, so we want to do a significant refactoring of the internals to make Pandas faster, use less memory, make it easier to extend, to overcome some of the limitations. Just a few things. So for example, one of the known limitations is that you can't have integer values you can't have missing values in integer columns, and you can only have, if you have missing values, it has to be a float column. So that's one of the one of the known limitations that we want to try to solve with a Pandas 2.0. Also, improved in performance, better utilization of more modern hardware systems, better control of memory usage. Currently, with a very complex internals or the representation of the data frame object in memory, it can be very difficult to predict how it is exactly stored in memory. We take, therefore, with a lot of operations, copies have to be taken to be on the safe side. So we want to improve that, have a much clearer memory model, so it will be easier to reason about it, to extend it, etc. Also, currently we have, on the one hand, NumPy data types, but also the in-house data types. We want to make that cleaner and more aligned. And also to have a C API to be able to, at a lower level, talk to Pandas. So if you're interested in that, there is a link with some of the design documents where you can read more about it. Now, of course, few of the what I mentioned about Pandas 1.0, Pandas 2.0, it's still mainly ideas and quite some work. Just to give you an idea, so we have a quite increasing user base. I don't think you have to look at the numbers, it's from PyParis, I don't know how reliable they are, but just to illustrate, it's rapidly increasing user base, but Pandas is actually developed at the moment with only 6 to 10 regular contributors, depending how you define contributors. So there is certainly all those ideas will require a lot of work, where we can use help. Those ideas about Pandas 2.0 will also impact users because APIs will change and things like that. So also there, feedback and what you think about that is certainly needed. Therefore, I want to end my talk with a few slides on how you can help. To start with, you can complain. I know a lot of people have a lot of complaints about Pandas. They will curse on Pandas if they use it. So don't just complain, but complain publicly. And if you do that, maybe don't really complain, but try to turn this into constructive feedback. It's very useful. Or turn this into contributions to the ecosystem in code or in feedback. That's certainly very useful. If you want to do this, you can open an issue, or you can follow the Pandas dev mailing list and try to be involved there in discussions. So you can contribute feedback, which is very useful to us. You can also try to contribute code, and as Sylvain mentioned in the first keynote, start small. I looked back at my first contribution to Pandas, and it was actually a typo fix. So you don't need to start with big contributions, or you don't need to think that you have to be an awesome developer. I just started with a typo fix, and now I'm a Pandas core developer. So if you don't have time to contribute yourself, you're maybe an employer, or you can convince your employers to fund, to let your employees to allow to contribute to Pandas in their time. We have a few of those companies. Continuum Analytics and 2 Sigma employ Pandas core developers. I work at INRIA, but this could be a lot more companies. And finally, you can also donate money. So through the NumFocus organization, you can donate. And just to end, of course, what I said here about Pandas applies to many of the open source projects in the ecosystem. Many of those can use your help. Voilà. Thanks for listening, and if there are any questions or feedback, I will be here the 2 days. So.